Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will talk to you about chi-square test for independence of two variables. So just like before, this assumes that you've done your reading for this section, which is 12.3. You're familiar with the main terminology, but you might be struggling with the computational part. So that's what this video is all about. You will need access to the Excel file that I created for this section, this worksheet, second page, which talks about problem for independence, and also we will need access to our course on MyMathLab. In particular, we're going to need to use Table 8, chi-square distribution table. So it's loading at the moment. Okay, let's go ahead and take a look at our problem and see how we can approach it. Suppose Bank of America would like to investigate if credit score and income level of an individual are independent of one another. So here we have this contingency table that tells us information about 400 adults, which is a nice big sample size, so we can definitely do some inferential statistics here. And for example, let's just pick one of the cells. So this number right here, 40 people in this sample, have credit score less than 650, and the income is between $100,000 and $150,000. Okay, so our goal is to see if there is a relationship between these two categories, credit score and the income level. Okay, in general, that's what we want to do for this type of problems. We want to see if the two variables are independent. Let's take a look at what we got here. Okay, the null hypothesis will always say that rows and columns are independent. So that's a generic statement. In the context of the problem, we will say credit score and income level are independent. Okay, you can also say that they're not related. All right, the alternative hypothesis would say that they are dependent, and that is always going to be the case. You can say are not independent, or you can say dependent or related. Okay, all of these statements are equivalent or acceptable. Okay, so that's what we want to find out. Is the relationship between credit score and income level? Okay, so how are we going to do it? Now we're going to use our Excel file, and let's go back. Let's go to the second tab, and over here I already copied my observed frequencies into a matrix, or you can call it a table. So I have 4 categories for the income and 3 for the credit score. Okay, so they're all copied here, and I'm also creating summation for each of the column and each of the rows, and I'm going to need these numbers when I compute my expected frequencies. So over here you would just say sum and sum up these 3 cells. Okay, I've also already computed expected frequencies, but let me go ahead and show you how it would be done. So the expected frequencies are computed by multiplying the total for the row times the total for the column, and then divide by the entire total, grand total. Okay, so to save some time, I already have them computed here, but let's just delete one of them. So let's say this one is gone. So how would I compute this value? I said that's equal total for the row is 80 times total for the column 130, divide by 400. I get this value right here. Okay, and also I'm just checking that everything adds up to 400. That's not something you have to do, but I think it's a good habit to have. Okay, so these are my expected frequencies. Okay, so now let's go ahead and just do some investigation, just observing these values. Let's see what's going on here. Well, for this category right here, observed frequency is 63. Expected is 60. So we have 3 more people in that cell for observed category, right? But is that significant enough? Well, that's hard to say just by looking at one cell. Let's take a look at this one right here. We have 17 people for observed frequency and 19.5 for expected. Again, is there a difference? Yes. Now we have fewer people in the sample than we would expect. So the question is, for the entire sample, okay, is there enough difference in observed frequencies and expected frequencies to say that there is a relationship between the two variables? Okay, so once you compute all of your expected frequencies, it's always a good idea to just check, okay, just kind of try to make sense out of these values. Okay, 22 and 18, are they different enough? Well, it doesn't seem like too different, right? Now, a lot of times your intuition will say, okay, well, that doesn't look like there's too much difference. But you got to be careful. It's a good idea to make some sort of decision what's going to happen, but still we're going to check this with statistical computations. So how are we going to do it? What I've done over here is very similar to what we've done for goodness of fit. Okay, remember we said these are our observed frequencies and expected over here. So we find these numbers right here by doing observed minus expected squared divided by the expected. And then we sum it all up, and that is our test statistic. So for test for independence, we're actually doing exactly the same thing, but we have to be careful how we're going to plug in these numbers. So I copied my observed frequencies by column and just copied them into this one column. And then I did the same thing for expected frequencies, but I want to make sure that my values align. So 26 and 30 go together, right? 63 and 60. That's a pair, okay? And then 40 and 37.5. That is also a pair, okay? So once I have all of this copied, I'm going to do the same computation as before. So it's observed minus expected squared divided by the expected. Okay, let's copy all the way down. I have all my values. And now, let's see, let's go back to our worksheet. What do we have? Okay, so if you were to submit this for credit, you would fill in this table right here, right? I'm not going to copy them down, but you would copy these values, 30, 26, 24, and so forth. Okay, and what do we want? We want 0.01 as our alpha. So that's that. Let's see. Rows. We have 4 rows. We do not count the row for the total. So we have 4 categories for incomes. Column 3. We have 3 categories for credit score. Okay, degrees of freedom. Remember, for goodness of fit, our degrees of freedom represented number of categories minus 1. Now here, it's something similar. Now it's number of rows minus 1 times number of columns minus 1. Okay, so you can do this computation. It's 4 minus 1, which is 3, times 3 minus 1, which is 2. Okay, so 3 times 2 is 6. Okay, we found our critical value and the test statistic and the p-value. So all of that is found. Okay, let's see. Critical value. We have that computed. Let's say you don't have this spreadsheet and you want to use the table. Let's go back to our table. Okay, it didn't load. Let's see if we have any good luck with loading it. Okay, well, what would you be using? Well, you would be using 6 degrees of freedom and alpha level 0.01. So you would be looking at the table and the value that's in the intersection for the row 6 and 0.01. If we have any luck, this will load. Sorry about that, this is not loading, but oh, maybe it is. Okay, let's go back and see if we can actually come up with a conclusion. Now, all right, that's our critical value. That's the test statistic. Remember, the chi-square test is always right tail. So the critical value is way to the right of the test statistic, right? Or test statistic does not fall into the critical region. You can also take a look at the p-value. This is a huge p-value, especially compared to 0.01. So either one of the methods you're going to use will give you the same conclusion. Okay, so let's actually fill this out. Test statistic is 3 point something, right? So let's see, 3.32. The critical value from the table. Did it load? Ah, no luck. Okay. Well, over here we have it. 16.81. 16.81. That's our critical value. What is the conclusion? Yeah, we failed to reject. Failed to reject H null. There is insufficient evidence to claim that credit score and income level are dependent. Okay, which means they're not. Well, they could be, but this sample is not good enough to conclude. Okay, well, something is up with my math lab. That's all right. Okay, so that is our conclusion. We failed to reject. Either way, you're going to use, whether it's chi-square test statistic or the p-value, you're going to get exactly the same conclusion. Okay, so that's how you guys would do your computation in Excel. So the difference will be for what, for your problems in what sizes of these matrices. Okay, most of them will actually be smaller. So if the matrix is smaller, that's okay. The computation will be exactly the same. You will just have to adjust your table over here, okay, and your table for expected frequencies. But the computations will be exactly the same as before. Okay. All right. Well, thank you for watching. I hope this was helpful. And this is the last video for the course. Congratulations on finishing it. Well done.